Good morning, everyone. Welcome to our broadcast of Basics of Reclosure Testing. Today, we'll be talking about the basic principles of recloser operation and their role in the transmission and distribution systems. My name is Greg Valdez, and I'm the Marketing Communications Manager for Megger North America. I'll be acting as the moderator for today's presentation. If you have any technical issues or questions for our presenter during the session, I will be supporting you. On the right side of your screen, you will see a control panel that looks similar to this one. You can submit questions at any time during the presentation by typing in the box highlighted in red. You may also notice there are two audio options, telephone and mic and speakers. The mic and speakers option uses voice over IP, so you may experience intermittent audio lag due to bandwidth. At any time during the presentation, you can switch to the telephone audio option. You will receive a copy of the presentation afterwards, and remember, you can ask questions at any time during the presentation. I will interject your questions as we have time. Our presenter today is Vijay Sundaram, Megger's Application Engineer for Relay Products. Vijay is based out of Dallas, Texas. Thank you for joining us today, Vijay.
Good morning, folks. How are you all doing today? So I guess you can't hear me. Let me know if you can't hear me. I'll make sure that there are a few changes here. First of all, let me introduce myself. My name is Vijay, and I'm the Relay Application Engineer working for Megger. I joined Megger in 2012 and focusing on the relay products such as the SMRTs and the MPRTs and even the previous generations like Pulsar, Epix, SR76, SR51. I also deal with the accessory products like the MGTR, the GPS controllers as well. So if you have any questions, you can always give us a call to our technical support and I'll be happy to help you. Today, the focus of this presentation is basic reclosure testing. In this presentation, we'll be talking about the definition of autoreclosures. What is the need for autoreclosures in your system? Why do you need it? We are going to see some of the advantages of having an autoreclosure in your system. Most importantly, if you guys don't know much about autoreclosure, we are going to see how it works just to get a feel of how it is in the system and what happens in the system when you install your autoreclosure. After that, we are going to see some associated definitions just to make sure that you know what those are. We're going to continue from there on the types of autoreclosures. There are a few types. We're going to see that as well. And after that, we are going to move on to the application side of autoreclosures. We're going to see where it is used and how it is used, how it is set up in your system. As the topic of the presentation, we are going to see how you can configure your relay for doing the autoreclosure function. And finally, I'm going to introduce you to Megger's solution side of it. We have a unit called ERTS. I'm guessing it has not been released to the customers yet, but we have already designed and designed the unit, and it is ready to launch. So I'm going to talk about that, how it is used and how it is working, how it will be working in your system. As Greg was mentioning, you can always enter your questions on the right side of your screen. You'll see this, and you can enter your questions if you have any. Before going into the presentation, I just want to give a quick background of what I do and what my background is. I did my Bachelor of Electrical Engineering in India, and after that, I did my Master of Science in Electrical Engineering again, focusing on power systems. mostly dealing with automation systems from North Carolina State University. And after finishing my master's, or during my master's, I was working with Siemens as an automation engineer. I was designing IEC 62050 substations. After that, after Siemens, I was working for a small company in Pennsylvania. It's called Unelsys. And during that time, I was designing IEC 62050 substation, also doing some AC, DC schematics, and doing all the correction diagrams for relays. And in 2012, as I said before, I moved to Megger, and from there on, I have been focusing on the relay products of Megger. Today, we are going to talk about the Autoreclosure. For those of you who don't know much about Autoreclosures, the basic definition of Autoreclosure, you can think of the Autoreclosure as a switchgear or circuit breaker. So if you know about circuit breaker is nothing but a switch with an arc quenching mechanism. The Autoreclosure is nothing but a circuit breaker with an automatic closing mechanism. So according to Wikipedia, Autoreclosure is a circuit breaker equipped with a mechanism that can automatically close the circuit breaker after it has been opened due to a fault. So whenever there is a fault, the circuit breaker opens or isolates that part of the circuit, and the Autoreclosure or the auto-reclosing mechanism will automatically close the circuit breaker and restores the normal operation of the system. For those of you who don't know, the Autoreclosure is represented by the ANSI number 79. So if I say 79, it means the protection function Autoreclose. Now we are going to move to why do we need reclosure in your system? Well, first of all, when we talk about faults, not all faults are damaging the system or permanent faults. Some are transient faults. As you can see in the slide, almost 80% of the fault that occurs in our system are transient faults, which is only there for a couple of cycles or a couple of seconds, and then it disappears, like lightning or arc flash or something like that. So the first picture here shows there is a lightning on the transmission line. So that is going to last for maybe a couple of seconds. So it is going to disappear after a couple of seconds. So that I can consider that as a transient fault. The second picture looks more damaged. So this I can consider as a permanent fault. But in the system, the third picture shows you a branch of a tree on a transmission line where the current is capable of destroying or completely burn the branch, and then after a while, maybe 5 or 6 or 7 seconds later, your system or the fault clears by itself. So you don't have to do anything about it. So that I could consider that as a semi-permanent fault. Some of the examples are animals or branches on the lines. That constitutes about 13% of faults that occurs in our system, and only 7% of our faults are permanent, caused by storms or you name it. The final one right here, that is a special kind of fault. I want to call that as a YOLO fault, which is you only live once. So those kinds of faults are permanent, and you need to clear those faults before you restore your system balance. And that is one of the main reasons why you need a reclosure. In case if the fault is not permanent, you want to restore the system, the generators again, or restore the stability of the grid again. Other important need for the reclosure is to maintain the standards like SAIDI, SAFI, and MAFI. What is SAIDI? Probably most of you already know about this. SAIDI is called the System Average Interruption Duration Index, and that tells you the average outage duration. It is a ratio of sum of all the customer interruptions duration divided by the number of customers served. So you want to keep this index within the threshold, because higher the index, it means the interruptions are more in your system, and generally your customer satisfaction is very low when you have lots of interruptions in your system. The second one is SAFI, which is the System Average Interruption Frequency Index. So that is the average number of interruptions, and that is given by a ratio of sum of all customer interruptions by number of customers served. Again, this needs to be as low as possible, because the occurrence of the faults or occurrence of interruptions will generally lead to the outage time as well. So you need to keep that under a specified value. The final one, MAFI, is the Momentary Average Interruption Frequency Index, and that's the average number of momentary interruptions in a year. Again, same as before, you need to keep that index as low as possible. So I'm going to talk about some of the advantages of the reclosure, having a reclosure in your system. First thing is, yes, it does minimize the power interruption time. So whenever there is a momentary fault, you restore the system, or you automatically close the circuit breakers, and the system becomes normal again. So you would minimize the power interruption time. After that, not just that, so when you have a reclosure in your system, especially in a transmission line, you're restoring the system capability and also the critical system interconnections. Sometimes, there is a tie, and whenever there is a fault happening in the tie system, you might want to restore the power flow as soon as possible, so that a huge area on the other side does not get affected. That in general, I can consider that as maintaining the system stability, because I'm bringing all the generators and supplying all my loads. There is no interruption in between. There is no isolation. There is no part which is not supplied. So I consider that as a system stability as well. So it is used for maintaining the system stability. One important thing is it reduces a lot of manpower, because imagine there are no auto reclosures, or there is no automatic reclosing mechanism. So even a transient fault, or even any fault for that matter, will open your circuit breaker, and there should be a manpower who goes to that specific spot or specific circuit breaker and manually close it. And so there are numerous faults, hundreds of faults occurs in a day in a given area. So if you don't have an auto closing mechanism, pretty much there has to be a person who closes that specific circuit breaker. So that will again lead to interruptions or longer interruption times, in decreasing your or making your indexes that we discussed in the previous slides more, and it causes a lot more problems. This also gives you the reclosures also gives you the ability to run the substation unattended. I mean, it is not recommended, but still, you don't have to have too much of manpower closing the circuit breakers all the time. And finally, overall, which is the most important thing, is it improves customer satisfaction, because after a moment's interruption, the the auto reclosure is going to close itself, and then your power supply is going to be back. So if you're going to Hoboken, New Jersey, and to view the beautiful view of New York skylines, imagine all the lights are off, and you'll be disappointed as well. So when you have a reclosure in your system, you always close the circuit breakers and restore the power. Now, for those of you who don't know, or those of you who want to know the basics of auto reclosure working, I have simplified the model. So I'm guessing you can see my mouse there, or the pointer there. So I have a source supplying a load. All right. So that's a basic system. So I have a source supplying the load, and I have a circuit breaker here, and I have a controller here. I have to give you a better picture of that. So this is the auto reclosure on the system on the pole, and the controller will be usually on the base of that pole. So that would be my circuit breaker or auto reclosure mechanism here, and all the CT/PT inputs are going into the controller. We are not focusing right now on the controller itself, but controller is kind of like the brain behind the operation. So between the circuit breaker and the controller, all the control signals and the breaker statuses are communicated. The CT/PT inputs are going into the controller as well. So the controller sees the status of the breaker, whether it is open or not, and it will also see what is the current level on the transmission line and the voltage level on the transmission line. For understanding purposes, I have a controller, or you can imagine a controller with a 4-shot lockout. I'll explain you what a 4-shot lockout is again by the end of this working model. So you have a 4-shot lockout here, and the controller is always monitoring the current and the voltage levels, and also it is aware of what the circuit breaker status is, whether it is closed or open. The red here means it is closed. It is the source is supplying the load through the breaker. So everything is working normal, no problem yet. And imagine there is a fault, and for our understanding purposes, to see what a 4-shot lockout will look like, we'll imagine a permanent fault that happens in the transmission system. So that'll be the second step. So once that fault occurs, naturally, what will happen is your source will supply the fault. So the current, the amplitude of current goes up, the voltage goes down, and that will always be monitored or sensed by the controller. So this controller is going to see high amount of current, and let's say this controller has another function, the instantaneous function, where if higher the current, then it trips the circuit breaker as soon as possible. So the controller is going to send a trip signal through this bridge or through the cable. So this controller sends a trip and opens that circuit breaker. Along the path of this presentation, we're going to talk about what happens in the circuit breaker, what happens in the controller or the relay, and everything. So for now, the controller sends a trip signal into the circuit breaker, and that are the auxiliary circuit of the circuit breaker, and it trips the circuit breaker. So after the circuit breaker is opened, since we have a controller with auto reclose capability, the 79 function kicks in, which is auto reclose function. So this is going to kick in, and it closes the circuit breaker again, just to make sure that it is not a not a permanent fault. It doesn't yet know whether it is a permanent fault or not. The controller doesn't yet know whether it is a permanent fault or not. So after sensing the fault in the third point, after sensing the higher amplitude of voltage, higher amplitude of current and lower amplitude of voltage, it assumes that there is a fault in the system somewhere down the line, and it trips that circuit breaker. After it trips, the 79 function kicks in after a time delay. We're going to discuss about the time delay as well. So after a time delay, the 79 function kicks in and issues a reclose signal into the into the circuit breaker. So after the circuit breaker receives the reclose signal, it closes back again. So the switch is closed. The source is again supplying, in this case, load and the fault, because we have assumed our fault is a permanent fault type. So right now my source is again supplying the permanent fault and the load. So again, naturally, the current is high and the voltage is low. So this is again monitored by the CTPT inputs into the controller. So the controller sees a high amount or high amplitude of current. So what does it do? The 50 function, or whatever function it is. I have taken the instantaneous function. It could be any other function as well, like a 50G, which is the ground fault, 50N, neutral, or for that matter, it could be directional, or any other protection function. So the function again, that protection function again sends a trip signal, and that trip signal will open the circuit breaker. All right, so now it is open. After the circuit breaker is open and after a time delay, the 79 function sends a reclose signal after that again. So that will be my second shot of reclose. All right, so it tries to close the fault just in a hope that it might be a semi-permanent fault, which is taking a longer duration for the fault to clear itself. And since my circuit breaker is closed, after that, again, my source here is supplying the permanent fault and the load as well. Naturally, the current is higher, voltage is lower again. My 50 function or any other protection function trips the circuit breaker. And after it trips, the phenomenon are that the whole mechanism is repeated again. The 79 function recloses and sees whether the system balance has been restored again or not. So that'll be my third shot into or third reclosing procedure that I follow. And moving on, again, there is since this is a permanent kind of fault, your source is supplying the fault, higher current, trips the circuit breaker, and after it trips the circuit breaker, after a time delay, my controller is going to try for the last time to see whether the fault is cleared or not, and it issues the reclose signal through the reclose circuit, and that will be the fourth shot. So after the fourth shot, the circuit breaker is closed. Now my source is again supplying the permanent fault, and then the voltage and currents are measured here by the CT and PT and passed on to the controller. My controller sees at this time, you already know by yourself that the current is going to be higher and the voltage is going to be lower than the threshold. And finally, the 50 trips. Since my controller was programmed for a 4-shot lockout, I'm not going to issue any more shots or any more reclose signal to see whether it is going to be a permanent fault or a temporary fault. At this point, for the controller, it doesn't matter whether it is going to be a permanent fault or a temporary fault, but the fault is not cleared. So there is a very possibility that it might be supplying a fault. It could be a person trying to catch the transmission line or doing something wrong there, so it is going to completely lock out or completely open, and it is not going to issue any reclose signal after this. At this point, after the lockout, what they have to do is they have to send the person into the circuit breaker, to the control room and manually close. After clearing the fault, they have to manually close the circuit breaker after this. As I told you before, this is the timing scheme. It is not drawn to scale, but it will give you an idea of what is happening in the relay, the protection relay, what is happening in the protection relay, what is happening in the circuit breaker, and what is happening for specifically the 79 element. So let me first just talk about the protection relay. So this red line means that's when the fault occurred. So when the fault occurred, going back to this picture, when the fault occurred, the relay is going to see that fault here, mainly through the CTs and PTs. So it will take its own operating time to operate. So it operates, and then after a while, it resets itself. Meantime, what is happening in the circuit breaker? Once the relay operates, or the controller, in other words, once the controller operates, the controller is going to send a trip signal to the auxiliary circuit here to the circuit breaker. So once it receives that trip signal from the controller or from the relay, once the relay operates, the trip coil is energized. And the trip coil, after the trip coil is energized, the contacts are separated or opened. In other words, it takes its own time to open the contact, and meanwhile, the circuit, as we discussed in the first slide, the auto reclosure is nothing but a circuit breaker with an auto closing mechanism, and a circuit breaker is nothing but a switch with a arc quenching mechanism. So once the contacts separate, to prevent the arcing, there will be an arc quenching method, and the arc is quenched, and the contacts are fully open after a while. All right. So starting from receiving the trip signal from the relay until the arc is quenched, it is called the operation time of the circuit breaker. And after the arc is quenched until I'm going to come to this point here. So what happens? So we saw what happens in the circuit breaker after it receives the trip signal from the protection relay. Meanwhile, in the 79 element, that is also inside the circuit breaker, also inside the protection relay, once it receives that trip signal, or once it sees the trip signal because of any protection function, the reclose is initiated, or the 79 function wakes up. And it is going to go through its own time delay. We're going to see how it looks like in a relay configuration. We're going to see that. So the 79 function wakes up and it starts its own countdown. And after that countdown ends, usually that is called 79 OI1. That's the open interval 1, or for the first shot. So after that timeout ends, the 79 element through the relay sends a reclose signal, or through the controller, in other words, sends a reclose signal into the circuit breaker. Again, I'm going to say the same thing with this picture. So the controller, right now the circuit breaker is opened because of a fault, and that is opened by the controller again on a 50 function or whatever function it is enabled. After the circuit breaker opens, the 79 function is initiated by the trip signal that is sent by the controller in the beginning, and then the 79 function will have its own time delay. It's called 79 OI1, open interval 1. And that 79 function inside the controller will issue a reclose signal to the auxiliary circuit, or the reclose circuit in particular. So that will be the close command sent by the 79 element into the circuit breaker. And once that receives the circuit breaker, once the circuit breaker receives that close command, it will start energize. The close coil gets energized, and that close coil will try to close the contact fully. All right. So this red line that is here means when the circuit breaker closes, for our understanding purposes, it is closing on a fault, which means when the circuit breaker closes, the fault still remains, and the source is supplying this fault and the associated loads, whatever load connected to that source. So it is closing on to a fault. And what is going to happen is the protection relay or any other protection function inside that controller again kicks in, and it takes its own operation time to operate the relay. And once what happens here, operate means, is the trip signal is issued by the controller, and the circuit breaker again goes through the trip coil energized, and the contacts are separated. And after the contacts are separated, the arc is quenched, and the contacts are fully open. So the same procedure happens again and again until the 7th element goes to lockout. So from the close command issued to the relay lockout, it is called the reclaim time of the 79 element. Generally speaking, this is where the fault happened. This red line is where the fault happened, and this dotted red line is where the fault is actually closed, or sorry, the source is supplying during this time from this red line to the dotted red line. During this time, the source is still supplying the fault. So the source is still supplying the fault until the circuit breakers are completely open. So that will be your system disturbance time. Mr. Heidi Wanton Khan has asked, what does the 50 function have a specific name, like 79? Yes, the 79 function is called Autoreclosure. The 79 function is usually called the Autoreclosure function. The 50 function is called instantaneous functions, instantaneous overcurrent. 50 is usually associated with current, so the 50 function is called instantaneous overcurrent. 51 is called timed overcurrent. We are going to see, I just have a slide which defines everything which is discussed in this slide. So the operating time here of the relay means the time from inception of the fault to the trip coil energizing. That is this operating time of the relay. Operating time of the circuit breaker is time from the trip coil energization to the fault or quenching. That is this right here. So the dead time of the circuit breaker, which means time from the fault or quenching to the circuit breaker remaking, which means from the arc quenching or from the opening to the closing of the circuit breaker. The dead time of the 79 relay or the 79 function means time from recloser scheme initiation to the closed coil energization. That is this one and this one. Those are the dead time of circuit breaker and the 79 element. I should have put 79 element instead of 79 relay here. So reclaim time of the 79 element is the time from closed coil energizing to arc quenching on the next trip cycle. Reclaim time of the 79 element from the close command that is being issued by the 79 element to the complete lockout or on the next cycle. And lockout, again, we have discussed about this quite a few times in the previous slides. So the lockout nothing means there's not going to be any more short or reclosure signals sent back to the circuit breaker after that. So that is what a 79 lockout means. And as I told you already, after the lockout happens, there has to be a manual closing or manual fault clearance, and after the fault is being cleared, we have to close the circuit breaker manually. I hope by this time you understood the basics of how the auto reclosure works. If at all you have any questions just regarding that, send me or just type it in there, and we'll know if I still need to go back to the same slides and explain you how it works. From here on, we are going to talk a little bit about the types of auto reclosures. Now, an auto reclosure could be a single pole auto reclosure. That's a picture of a single pole auto reclosure, or it could also be a three-pole auto reclosure. So in case of a three-pole auto reclosure, whenever there is a fault on a single phase, like A to neutral, let's say, or let's say B to neutral, it doesn't matter if it is A to neutral, B to neutral, or A to B, B to C fault, or whatever it is. Whenever there is a fault, all the three phases are going to be opened regardless of the fault type. So what happens when you open all the three phases at the same time? There's a fair chance that the generators might get that sudden release of load from it, and then generators tend to drift apart a little bit when all the phases open. So after the protection function opens the circuit breaker or auto reclosure on all three poles, before it can reclose by itself, you need to make sure that it is synchronized before you close that, before you close the auto reclose. In case of a single pole, right? In case of a single pole, when there is a fault on B phase, just the B phase is isolated. Not all three phases are isolated. So naturally, the effect of discontinuing the load on the generator is usually negligible. But naturally it complicates the things a little bit more. So you need, in this case, when you have a single pole auto reclose, you need to make sure that you can select the phases. In other words, your controller should know which phase the fault happened, whether it is a permanent fault or an A to B fault or a B to C fault. The controller should know which phase the fault occurred. And that's easy because the circuit breaker, we have the CT inputs are going to be on all three phases. So the controller is going to see with increased amount of current on the specific phases where the fault occurred. The only thing is the controller should have 3 trip signals or 3 outputs assigned specifically for A phase, B phase, and C phase, and that should open the circuit breaker or the auto reclose in this case, single pole auto reclose in this case, just on those specific phases. It is not opening all the 3 phases at the same time. And associated with the single pole, you need to have an individual closing or tripping mechanisms on each phases. Naturally, it is more complex and more expensive because you're not just doing generally on all 3 phases. You're segregating your phases or faulted phases, and you need to have tripping and closing mechanisms individually for all the phases that you have. Now we can also distinguish auto reclosures based on where it is located on the system. So most of the time, the high voltage auto reclosures are mainly located in the transmission lines, and the main focus of that auto reclosure is stability and synchronization. So what the auto reclosure or the controller of the auto reclosure will be looking for is to maintain the stability of the system and to maintain the synchronization of the transmission lines. In case of a medium voltage, those are in the distribution system. The main focus will be on continuity of the power supply. So again, the auto reclosure does not decide whether it has to go for continuity of the power supply or the stability. It is the controller's job to decide whether the auto reclosure should issue a 4-shot or 3 shots or 2 shots or 1 shot. It is up to the controller to decide. So when you're designing or when you're deciding upon how many number of reclosure shots you need in your system, you have to go through your studies and then make sure, hey, in this point, I don't need 4 shots, I just need lesser shots. I can ask you a question. At this point, I don't have any way to ask you a question, but usually in a transmission line, when you talk about a transmission line, it will always have a single shot, not a 4-shot, but a single shot, or maybe 2 shots of reclose. Why? Because majority of the function sorry, I'm losing the chain of thought here because I'm reading through the questions. I'm gonna read through the questions at the very end because I'm losing my chain of thoughts. Anyway, coming back here, in a transmission system, you will have 1 or 2 shots, not more than that, because if at all the fault is not cleared in 1 or 2 shots, there might be a permanent damage. So you don't want to supply the faults, and in those high voltage transmission systems, when you're supplying the fault, your losses are a lot more compared to the distribution systems. Yeah, and majority of the permanent faults, like a tree falling on the pole or any other kind of permanent faults that you will see, will not happen that frequently on a high voltage transmission line. So the occurrence of those, like trees growing in or branches falling off, will not happen that frequently on a transmission line, but those happens pretty frequently on a distribution line, like squirrels on the distribution lines near our houses. Those will happen here. So you will try to feed the fault. You can afford to feed the fault for at least 4 times or 3 or 4 times before you decide, okay, it's a permanent fault, I'm not going to feed that anymore, I want my security. So you will lock out everything. Now, we'll see some applications where mainly focused on the distribution side, we'll see some applications. There are 2 types. One is fuse save scheme, and the other one is fuse blow scheme. Talking about the fuse save scheme, so the reclosure first is set to a fast operating curve for 1 or 2 attempts. This blue line is the fuse. So you generally have fuse for all your system. The main discussion is whether you want to save this fuse or you don't care about the fuse and you want to blow the fuse. So in this scheme or in this design point, what we are going to do is we are going to save the fuse for a couple of times. So the fuse will have its own threshold. So what will happen is you will open the circuit breaker before the fuse will blow. So your your controller controlling the circuit breaker or auto reclosure will open the circuit breaker faster than the fuse blow time. After a couple of shots, it switches to the slow operating curve. So if the fault that triggered everything here is a permanent type of fault, will blow the fuse, and there will be a man, or they will send a line crew to replace the fuse and clear the fault before restoring the system again. Couple of advantages of using this fuse save scheme. This protects the fuse from any transient fault. So your transient, because of a transient fault, maybe due to a lightning or any other transient faults, your fuse will not blow. Again, the fuse costs a lot, or I wouldn't say a lot, but again, it is a cost to use, so that you can save the fuse for at least from transient faults. Some of the other advantage one more advantage for using a fuse save scheme is you increase the revenue for the utility because you're supplying your load, and in other words, the meter is running, or your meter is running most of the time. Your auto reclosure will make sure the circuit breaker is closed after a short time delay, and then you're supplying your load. So from the utility perspective, it is less downtime, and you'll be supplying your customers more or for more time. So that's a lot. It's more money for you. But the disadvantage is the temporary outages to the larger customers connected in the feeder. So what this means is when you're feeding larger customers, the transient faults causes temporary outages as well. So that will be a disadvantage using the fuse save scheme. The fuse blow scheme, this is quite opposite to what we saw. The reclosure is going to operate on the slow curve, and you have this fuse protecting your reclosure as well. So your fuse will blow even before the auto reclosures come into picture. So any fault, it doesn't matter, any fault causes the fuse to blow in the faulty area. So some of the advantages of using this fuse blow scheme is the outages happen only in the faulty circuit, not in all the you have to imagine a distribution or a ring type distribution here. So whenever there is a fault in that distribution ring, the fuse will blow and it will eliminate or isolate that part of the load, just that part of the load. Now the auto reclosure, which will be protecting the whole ring, but the fuse is going to blow only for the faulted line, not for the entire community. So it does not affect the larger customers, just the faulted place or faulted area. Some of the disadvantages are, again, as you can see, the fuse is blown here, so you have to replace the fuse, and you have to make sure that the fault is cleared and replace the fuse. That is going to cost you a little bit of money, and more importantly, you will lose a lot more money because that specific customer where the fuse is blown is not going to get his service for a couple of hours, maybe, depending upon how fast your maintenance crew is. So that revenue is lost. So you know what a fuse blow scheme is and the fuse save scheme is. If you ask me a question, which scheme is better, I would have to say it entirely depends upon the system that you are trying to protect, and it is entirely up to the system designer whether he wants to save the fuse or blow the fuse. In other words, it means my answer would be whether if you're rich and if you can afford the fuse, you can go for that, or if you want to save the fuse, you can also do that. What happens in the transmission lines? What kind of scheme is used, whether there is a fuse or whether the fuse save scheme is introduced or a fuse blow scheme is introduced. I will leave it up to you to Google it and see if you can come up with an answer. You can always ask me that question. I will show you, I will give you my email address, and you can always ask me as well. So you can also make that 79 function not reclose the circuit breaker. But first of all, before going to that point, we're going to see what starts the 79 function in the first place. So in this very simplified picture I showed you, everything is under normal condition. Your circuit breaker is closed and your source is supplying your load and everything, and that there is a fault that occurred. As soon as the fault occurs, your protection function, either a 50 function, 51 function, 27 under voltage or voltage, a distant element 21 function, will pick up that fault, and that will open the circuit breaker. And that is what is triggering your 79 function. So after a time delay, your reclosure or 79 function wakes up or activated, and then it starts working or it starts sending the reclose signal. That is also given in this picture. So your relay protection is what is initiating your 79 element. So your main protection function is what is starting the auto reclose function on your controller, or generally speaking on your relays. What might be blocking the 79 function operation? Well, the first thing is the circuit breaker may not be ready, which means circuit breaker is still going through the open sequence. It is not completely open yet. You cannot close something which is not open yet. So that might be blocking your 79 function. That could also, it could be a manual operation of the circuit breaker. That could be a communication fail, which is making the 79 function not reaching the Reclose circuit or the auxiliary circuit. And some other things. Circuit breaker fail detected by the breaker failure and the pole discrepancy relay. So that could also cause blocking of your 79 function. Usually I ask you guys what might be other things that is blocking the 79, 79 function. But in this case, it could be, I cannot ask you a question directly. So this could be an interlock. If there is an interlock in your system, that could also block your 79 function. I have 5 more minutes, I guess, so I'm going to go through my presentation. I have a couple of more slides, not a lot, a couple of more slides. I have some other interesting things as well to say, so I'm going to rush through as much as possible. So if, I talked to you about the settings of the relay. So in a typical, I have chosen the SEL 351R. I'm guessing most probably the Cooper relays and other auto reclosure relays will also have the same settings in there. So first of all, you need to make sure that the element is enabled. That is a E79. Depending upon the settings of the E79 on the relay, it'll notify you as an engineer or a settings engineer. You will know that the element is enabled. And after that, if you come here on the reclosing relay topic on the settings page, you will see 79 OI1, OI2, OI3, and OI4. As you can see, my first shot is pretty faster than my third shot. So my first 2 shots are faster than the other shots. My third shot waits for 300 cycles. This is just an example, a typical example. It varies according to whatever system you have. So my first shot is faster so that any transient fault is cleared. The more number of shots I go, I wait for more time. In this case, the 79 OI4 here is 0. What it means is there is no 4 shots. It is only enabled for 3 shots. So the 79 RSD, which means reset time from Reclose. So I'm going through the shots one by one, and right now my recloser has issued 2 shots already. And after the second shot, suddenly there was a semi-permanent fault in the system and the fault cleared. So the system is coming back to normal. My system has come back to normal in this case. So I don't need to go for a trip. My 50 function is not active anymore because the system is normal. My relay is seeing normal voltages and currents, so it is not going to trip after this. So in that state, in that normal state, I have to wait, in this case, 1800 cycles for it to become reset from that reclose cycle. The 79 RSLD means reset time from lockout. So after I locked out and after I cleared all the fault and manually closed the circuit breaker should remain closed for at least 600 cycles for it to get out of that reset phase. The reclose supervision time limit, that's the 79 CLSD, that's the reclose supervision time. I'm going to keep moving forward, but if you have any questions, you can always give me an email and I'll explain you that. I'm running out of time. So there are different connectors available, 14-pin and 32-pin. So this is your auto reclosure. This, as you can see, this is going to be a 3-pole, I guess. So that is connected to the controller through a cable. And this cable could be a 14-pin, 19-pin, or 32-pin. Typically, when you're testing this controller, you'll be testing the controller more of not explicitly on the auto reclosure. You'll be for you to test the controller, what you will do is take that cable and you have to remodel that so that you distinguish the CT connections, your PT connections, your trip circuit contacts, your closed circuit contacts, and everything that goes into the relay test set. That will be the typical connection method. So you have to create your own cable such that this connection is made, this communication is made. Last year, what we did was we designed a system or interface. This is called Electronic Reclosure Test Simulator. So it has the 14-pin, 19-pin, and the 32-pin plugs available. What you're going to do in this case is you take a cable. So you take the same cable, actually. You can have a spare cable of the same type that you're trying to test the controller. Take that cable, connect it between here and here, but whichever it is, whether it is a 14-pin, connected to the 14-pin cable insert. If it is a 19-pin, insert it here. If it is a 32-pin, insert it here. And your relay test kit should have the single pair cables or the voltage cables and the connector cables. This is much easier to make, which is already available. It doesn't matter what relay test set you have. It could be anybody else. It doesn't necessarily need to be Meggers, but it could be anybody else. So you can make those connections here. And you can have this as an interface between your controller and the relay test set. So it is a painful job to make this connection every single time you go to a pole and then make the connections from the controller to the relay test set. You have interpreter, if you want to consider it that way, or an adapter kind of thing in between, which takes care of all the trip signals that is coming from this controller through that 14, 19, or 32 pin. And the breaker statuses also. Everything comes inside of this these 3 pins, either one of those 3 pins. You will not be using all the 3 pins at the same time. So from the controller, it comes inside here, and you would have all the connections, the CTPT connections, and everything distinguished inside of it here, and that goes inside. From here goes to the relay test set. So this way, in case of Megger, you have already a test module for your 351R, your 651Rs, your Cooper reclosures, and many other reclosures as well. So you have the test modules. We call that as Advanced Visual Testing Software, AVTS. So you can use that software on your laptop to control the relay test set, and it automatically tests all the functions of the controller using the relay test set and this ERTS box or ERTS unit. So that is the solution that we provide. We also provide the relay test set. I can talk about the relay test set. I might need 4 more hours, and I'm not going to take that. So but again, if you have any questions, please ask me or Greg or anybody in the marketing or sales what type of solution we provide for testing the auto reclosures in your system. We'll be more than happy to provide you. So in summary, what we have seen so far is reclosures definitely will improve the reliability and the stability of your system. And indirectly, actually, it also increases your revenue because your downtime is low. Again, I just want to remind you that not all the faults are permanent faults. Only 7% of the faults remain after the four-shot lockout. 80% of the fault is cleared automatically after or 80% of your fault is transient fault, so it clears it within a couple of seconds. So if you have a reclosure in your system, you automatically reclose and your system is restored again. So that's kind of like the most important thing we saw. And we also saw the ERTS unit. We designed that last year, and I'm guessing we haven't released that yet. It'll be released to the public pretty soon, so it is quite interesting to know about that. These are the sources of where I copied all the things from, or where I gained the knowledge from as well. I'm gonna give it back to Mr. Greg, and thank you so much for your time. I appreciate it. And again, if you have any questions, you can always send an email to this guy. Oh man, this guy right here. Or if you have any questions on the sales side, that will be sales@megger.com. Canada sales is CA inquiries@megger.com. Hold on, let me give it back to Greg.
Thank you, BJ. Again, if you have any questions, you can still type them in and submit them now. We've gone a little bit over time, but if we didn't get your questions, we will follow up with you individually via email after the presentation. We will also be emailing a copy of this presentation to you in the next few days. The recording of this session will also be available on our website 2 weeks after the presentation. That's megger.com/US. When we close the webinar, you will be redirected to a survey. We would appreciate your feedback so we can continue to improve future webinar sessions. Thank you all for attending, and have a great weekend.